Hello, everyone. Welcome to episode 27 of AI in Real Life. And we are ecstatic to have Carey Lening here with us, joining us from Ireland. Hello, Carey.
Hi.
Hi,
Hi.
Carey.
So
It's
excited to be
it's
here.
just amazing to have you. Carey is the data privacy expert and just pretty much all around a very awesome person, as we got to learn recently. Carey, please introduce yourself. I don't know what
Sure.
people need to know
What
on a
people
need to
need
know
to know.
basis.
Okay, that's a tall order. Okay, so I'm Carey Lening. I'm based in Ireland. I work for myself in a small consultancy firm as well, called Castlebridge, and we focus on a lot of things, data protection, and of course also all the new nascent AI stuff. I tend to be more in the technical side of things, so focusing on DPIAs and things like that, because that's what is exciting and fun for me. Um, I come from a background of law, but as I was telling Elisa and Elena, th- I have been married to an engineer for 11 years, and I've worked in a lot of tech companies and for tech firms. I worked for Facebook for a while. I worked for Google. I worked for the shadowy Palantir company for a little bit, which was interesting. And then so my knowledge is kind of a bridge between um, kind of technical and legal stuff. And so I like to say that I know how to do the translation layer between those two communities. And lately I have spent my time thinking a lot about fractal complexity of technical issues relative to the law. And so that's what's been keeping me kind of up at night or interested or things that I've been thinking and writing about. I also write a blog, which I would hope people subscribe to because it's fun and interesting. And I sometimes swear a lot, and I put cats on it. It's called Private Cat Insights, and that's kind of where I am sharing my thoughts. I don't want to say wisdom because it's not quite there. It's not always fully formed, but it is where I'm sharing my thoughts and where I've been writing lately. So that's me.
Yeah, Carey, thank you so much for joining us. And we have a fascinating subject today. Um, we're going to be exploring whether large language models can unlearn, quote, quote, what they know, or whether they can forget what they know. And this is a very novel issue. And I remember, Carey, you asked this question in one of our previous podcasts when we were talking about gender, AI and privacy kind of intersection related issue. And I thought, wow, this is a really interesting. This is a really interesting question because, practically when it comes down to if you want to remove your personal data from the large language model, what can you do, and why should
Right.
you care? So that's why we're lucky to have Carey because she has a lot of thoughts about this, and I just wanted to just kind of um, you know in like broader strokes, let you our audiences know we will try to talk about this today. These main topics that we will center our discussion around, and we might digress, and that's okay. So yeah, we will just talk about what's this machine learning thing, and whether is it a thing, first of all, and if it is, why it's so interesting. And again, we will look into whether LLMs are capable of learning or forgetting things, and whether there is a difference between these two concepts, right? And then what
Mhm.
Carey mentioned at the beginning, this concept of fractal complexity, I had to do my research on that. I mean, I know fractals are pretty, but other than that, yeah, I didn't know as much about it. So it would be really interesting to talk about that as well. And just down to some more practical, I guess, points is that some of the methods of the machine learning that um, Carey and I Carey and us will discuss, and also perhaps some of the legal implications and what does the law say, and whether there are any any implications on data privacy, like AI compliance front. And yeah, and basically to set the stage, Carey, I was inspired by your comment during our prep talk. So it's a mess. Is it a mess?
Yeah, It's complicated. I think that's what it is. It's sort of like my old dating relationships. I used to just say it's just complicated. It's a mess. Um, and it's a well-meaning mess, but this is new technology, at least for as far as most people are thinking about it. Obviously, AI in some capacity and even language models um, and NLP have existed for some degree of time. Like these are not totally new. And so it's not really reasonable to say that this is all brand new, but the shift that happened in 2023 when the Google engineers came out with the paper "Attention is All You Need" really changed how large language models and machine learning and large neural networks were being developed. And that shift is still something that we're all catching up with. So it's, I think, what I start with when I am talking to other lawyers is fundamentally understanding that it's a mess because our conception of what we think LLMs are is not really accurate on a technical level. The easiest way to think about it is, do LLMs store personal data? And I like to take a step back and just kind of think about how and what LLMs are actually keeping track of and what that learning process is. Because obviously, stuff that's going in the training data and training models and things like that, a lot of times that 100% is personal data, right? It's grabbing crap from the internet, and the moment you're grabbing stuff from the internet, you're not really paying a lot of attention, and you're not doing good data quality or good data governance and filtering out what the noise is relative to useful, relevant information. That is going to include personal data almost always. And a lot of times the outputs are also personal data. If I ask ChatGPT or Perplexity, who is Carey Lening, it is going to spit out an output. And that output is actually surprisingly reliable. What gets super complicated, and what I think is an important area that's not really thought of, is all that wodge in the middle. That's where it's kind of a mess. Because that bit in the middle is kind of the brains of a large language model. It's how information is stored. And a really important thing to think about is that it's not stored like a database. So we have a conception, and the law has a conception that
Yeah, what does it say?
that well, the law and the GDPR and all these data protection laws are grounded in the idea of having information in a structured format, sometimes that, or a filing system, right? Basically in an ordered way. Now, there's going to be some people who are like, well, unstructured data, Word documents and everything else, that's also personal data. That can be personal data, and they're absolutely correct. But the better way to think about it is an LLM is kind of more like our brains, or more importantly, kind of like just an assemblage of numbers that is storing things, as opposed to some sort of ready reference that you can pull information out of, like a database or a file cabinet. I wrote an article recently, or am writing a series of articles on can machines unlearn. And one of the big things that I discovered and I learned about was that that filing system conception that the GDPR has, that it's a thing where you can pull a record out and you can do something with that record. You can change it, you can delete it, you can access it, you can process it. It's my husband calls it explicit. In other words, you have a record about someone, about you, Elisa, or about you, Elena, or I have a record about you guys in my database. I can pull that record out and do something with it. It is a fixed thing. It may exist in some weird way in the database, but it is a fixed thing that I can do things with. But there's nothing in an LLM that works like that, because data isn't being stored in a way that is structured in that way.
Mhm.
It's being stored as kind of vector embeddings, which is a fancy math term for basically saying the connections between how words and, more importantly, how tokens are close in proximity based on the training data that the system has learned from. And that is not the same as a file about you, Alyssa, or you, Elena. That is something else. And the law isn't thinking in that way. And so the law is saying you should be able to, LLM providers, do all the things that the GDPR or that the CCPA require you to do, like rectify information or delete information, erase information, or make sure that it's accurate. But if the system isn't a record, it isn't storing a record of you, how do you make that accurate? How do you delete it? How do you even necessarily access it? It's not going to come out necessarily in the output the exact same way. So these are kind of just fundamental shifts in how the technology works relative to how the law is thinking about it. And so that's kind of what I have spent the last 6 months of my life trying to figure out is, are there technical mechanisms in place that allow you to still comply with the law, or do we need to kind of rethink the law a little bit? And so that's what I've been working on.
Yeah, this is, I mean, when you were talking, I'm just kind of also thinking, because we actually had another episode earlier this year when we were talking to Patricia, and she's the CEO of the company that actually, they developed a process, a method on how you can identify the personal identifiable information, PI, right, in this, in this data sets or something like that. So this is it's just kind of, on that other side, when you're talking about technical complexities, I think it can be done, but it's not a trivial, as far as I understand, it's not a trivial thing to do. So yeah, even before you can, you can, whatever, ask the LLM to forget or like learn or delete, you have to, first of all, you have to identify this piece of data, and it's not like, as you were saying, you can just query the database like your SQL or something like that, and SQL, and then just get your results or something. So yeah, I guess this would be a good segue to just kind of start talking about, once I think we kind of set the issue, right? So yeah, we have this certain regulations, in the EU, in California, and other places. And I think the California right to forget or delete, right, the delete, I think it comes into effect in January 2026, but it is a law in the books. So yeah, so the question is like, what is it? Is it a learning? Is it forgetting? I mean, what's this about? What's the difference? Yeah, so if you could talk a little bit more about that.
Sure. So again, learning is something we go ahead.
No, I just wanted to say, before we jump into like really, really seriously deep stuff, I just wanted to say, you mentioned that you're talking to professionals, and yeah, the GDPR obviously needs to catch up, as well as pretty much all the existing legislation. But even when it comes to regular people, right? I mean, even talking about anyone who comes across with this technology, who is working or at least tried to work with this technology even once, right? The assumption is this tool has got something of mine. If it's an artist, my work, it was trained on my book or my painting or a piece of something. I wanted to be out of that tool. So the assumption is just, I'm going to let you know you trained on my content. Please remove it kindly and let's move on. Obviously, the state of play is totally different, but it's astounding to me how vast this misconception is when I'm talking to pretty much everyone around, across the board, professionals, attorneys, people who actually are in position to make decisions, obviously regular folks as well. So it's just, yeah, it's pretty, the just extent of it is scary to me still. And it's been 2 years, guys. This month is literally 2 years since ChatGPT kind of exploded into public consciousness. Obviously, the technology has been here for some time, but, for just all the people everyday lives just pretty much change. So
Yeah.
yeah.
I think it's worth taking a step back and just pointing out that the folks who want data to be removed are not completely wrong. Again, remember I mentioned the inputs, the training data itself, 100% unequivocally includes personal data. And so I didn't listen to that podcast where you were talking about the identification of personal data, or PII, but I do think that there are tools out there that can do this, and that is a valid use case, right? And then of course the outputs can also be personal data. And there is a school, or the concept of retraining a model is absolutely 100% a thing. An organization like OpenAI, or Google with Gemini, or Meta with Llama absolutely should, ideally, in a perfect world, be using good, properly sourced, ethical, copyright free, or at least licensed, non-personal data when they're training their models. It should be public. It should be, all the T's and I's need to be, crossed and or dotted. But that's not what they're doing. That's not what they have done. And the idea that, most of the laws have time frames around them. If I send a request to OpenAI, they have generally about 30 days, maybe a little bit longer, to comply with it. If it's super, super complicated, they can extend it a couple of months. But those are deadlines. Those are kind of fixed in the law. A retraining process takes a lot of time. ChatGPT, for instance, OpenAI, they're pretty regular about their retraining, but it's not 30 days. It's not even 60 days necessarily. It might be once a quarter. It might be a little bit later, depending on the model and everything else. And usually they're just releasing new models. Perplexity, even worse, because they're not even really controlling the model itself. They're using Gemini or OpenAI, I think, and then they're whacking a retrieval augmented generation, a more like a database on top of it. And so, excuse me, they have even less control over what the foundational model is being trained on in the first place. That cost of retraining is non-trivial. It's millions and millions of dollars. I think it was something like, cost OpenAI something like $78 million to retrain, or to train ChatGPT 4, I think. And it cost Google something like $113 million. That's silly money. That's crazy amounts of money. And to think to conceptualize, oh, well, okay, they're going to do that for every single time I file a data subject request, or a copyright holder files a takedown notice, or someone claims there's misinformation or CSAM or whatever. That's bananas. That's not living in the realm of reality. So should they have done it right in the first place? Absolutely, 100%. You're not going to get an argument out of me about that. Is that happening? Is that likely to happen? No, not because they should be given a free pass to it, but it's because we live in a capitalist society, and they're like, screw you guys. We're just going to do the thing we want to do because it's cheap. It's cheaper than doing it right. So there is a process. There are different kind of mechanisms for unlearning. Unlearning is just the process of trying to get the system, trying to get the LLM and the model to disassociate in some way the connections that it has made between kind of different embeddings, different token combinations together. It turns out that's an active area of research, and it's really hard. And so that part, I think, gets lost in the shuffle. When to their credit, the European Data Protection Board, they're trying to puzzle over this right now. They had a request from the Irish Data Protection Commission. and the Irish GPC was like, man, I don't know how to deal with this, but we got all these companies, we got Meta, we got Google, we got all these other folks. OpenAI is based in Ireland now, doing stuff with personal data. We don't know how to deal with it, and we certainly don't know what kind of obligations under the law they have. There was a bunch of questions that were asked, but one of those was around personal data and obligations to comply with the data protection laws. And the number of people who came back with one of two answers, which was, you should just be able to delete my data like it's a database, or technical complexity and hardness is not an excuse under the law. The frequency I heard those refrains just drove me a little insane. I mean, they're not wrong in the legal sense, but they miss the complexity. They miss what I call fractal complexity, which is to say these things are far more nuanced and complicated and technically difficult than I think unfortunately, most of my compatriot lawyers actually realize. And having a little grace and understanding of that technical complexity, I think would go a long way to actually addressing the fundamental problems in a way that doesn't just leave the big providers or any large language model providers just kind of shrugging and going, well, can't do anything about this. This is just, these are physics. This is how LLMs work. And so part of why I spent my time writing what I did is I really wanted to nail down, are the lawyers right, kind of, and the regulators right, or are the technologists right, or is there something in the middle? So that's where the unlearning and the learning about what these systems actually can do and don't do was, became relevant to me.
Carey,
Yes.
can you
Go ahead.
Can you quickly walk us through, first of all, fractal, right? Yeah, obviously everybody gets a sense of the word, but why it's so hard to just remove a piece of information, be it a copyrighted work or personal information, something. Just, it's a small piece of information. Just please remove it and that's it. Why it's so hard?
Well, there's the retraining aspects, right? So that's just, it's costly. It's complex in the technical sense. It takes time, it takes energy. You have to have engineers figuring out where the hell in the data set the thing is. You also have to have engineers figuring out what specific embeddings and weights, the parts in the system that say these words go together. Carey and Lening are closer than Carey and data or Carey and dogs. Those connections are sometimes really hard to find because kind of in the guts of a large language model, it's doing a bunch of different things. And while I think it's reasonable to understand that engineers and the folks that are doing machine learning training and modeling understand at a high level how this works, it's sort of a little bit like brain surgery. You have neurosurgeons who understand how the brain works. They understand, like, okay, if you cut this part out, or you do a severing between the cerebral cortex, it will lead to a result. But the details, what specific part to cut, and what the possible outcomes are, that is still really hard to nail down. And so it's hard to find the data in some respects. And it's hard to make sure that even if you find the data and you remove it from the training set, and let's say you retrain everything perfectly, that you haven't missed something, that the connections aren't there for other reasons, and that you are sufficiently attacking all the right parts of the brain to make the system forget. So I use the which Napoleon problem a lot in some of my earlier articles, or better still, which Ted Bundy. There are people that share the same name with famous people. There are parts of work that, some artists are totally comfortable with having AI learn them or learn about them. There is Wikipedia. right? Wikipedia is sort of, open, Creative Commons. And there are obviously public domain works. And so if you just say, okay, I want to get rid of Ted Bundy, you need to figure out which Ted Bundy, because you don't want to get rid of information about the serial killer because that could be relevant, right? That's public domain. That is factual information. You don't want to get rid of all the knowledge about public domain works, because it kind of mucks with the language model and how it deals with language generally, because part of how it is learning how our sentences and context and everything else is by being trained on huge volumes of literature and documents and technical information and Reddit posts, unfortunately, and everything else. So you don't want to lose all of the functionality of that. And so you have to find where in the system the specific data you want to remove actually is. That's super hard. There's different methods that researchers have spent time trying to, trying to refine. But those methods all have their own costs and benefits. That's the easiest way to put it. Catastrophic forgetting is probably the closest. It's a concern in a couple of different directions. There's concerns that the system's catastrophic forgetting in the context of basically the LLM is running out of, OpenAI, ChatGPT is running out of new information from humans. So it's starting to eat itself, and you have a little bit of an Ouroboros problem, and eventually it's starting to eat all the crappy AI generated content that may not be very good, and that's going to skew results, and that's going to do some things. The other concepts around catastrophic forgetting are going back to what I was talking about. You don't want to forget so much that the system stops being effective. So that's kind of what those terms are. So it's a game of refinement. It's a game of figuring out what that right middle is. And right now, that's still really hard and really expensive and very theoretical.
Yeah, in terms of catastrophic forgetting, it's like, when we think about LLMs and like any artificial neural networks, we think that they're modeled after, our brains, but that's not necessarily so. And I was just reading this research with a technique that is being offered to as a possible solution to catastrophic forgetting. When when you train LLM kind of to do the new task, it might forget everything that it learned before, right? So, but this is not how our brains are working. The human brain is working. So we don't necessarily like engage the entire brain to learn something new. And we just only engage that part that is relevant to the skill. And when we learn that skill, it's just kind of, that's how it's happening. But the way that LLMs specifically, and I think artificial neural networks are structured in general right now, the architecture is that everything is so interconnected. So if you change something in like section of of the nodes, it will impact the entire system. And
right.
and this new in this new approach based on Kolmogorov Arnold networks is being offered as to, I guess, kind of re-engineer or like rethink this entire architecture for the artificial neural networks to work kind of in a different way. So when you learn something, you don't necessarily, if you change something in the nodes, it doesn't necessarily affect or impact the entire system as a whole. So that was interesting. Yeah, I just came across this one this week, so I thought I would just throw that in if folks are also interested in this kind of research.
Yeah, and there's all sorts of people that are actually trying to come up with different models and different training and different kinds of things that are not the attention based learning systems that the chat GPTs are and things like that. And I'm sure people will come up with things. I didn't spend a lot of time focused on those methods because I kind of wanted to live in the pragmatic here and now and think about what the regulators were already thinking about. But I totally think it is plausible that within the next 5 years we may have actually solved this because we just changed how models work. We changed how they learn. Or we switch and go to something like small language models, where the data is more refined. Say it's a legal small language model where it might be trained on legally sourced, properly licensed data that doesn't include personal information, or includes personal information that we have decided collectively is public, right? We, in the US especially, the idea that, if you're in a court case, that information is considered generally publicly available.
That's right.
In the EU, it's a little bit more fuzzy, but that's reality. And so, like, I can see situations where if we switch to those types of models, those types of approaches, or this new neural network structure and design that's a little bit, I think he mentioned something about splines and other things, and it sounded kind of interesting. I can see some of these questions perhaps being addressed, but I'm thinking in the context of what we have.
Yeah. Yeah, and I think that's we also wanted to talk about basically the method, right? So we just kind of I think define the issue, but now, like, what can we actually do about this? Like, there is machine learning, it's a thing. I mean, what are the methods? What are the processes? And what actually can be done to make to make LLMs unlearn?
So there you have kind of the main listed categories that I was able to find, although I did a little bit more research too, and there's a whole new body of work on federated unlearning processes, which are also fascinating. So let's talk a little bit about these different methods, right? Exact unlearning is basically one of two things, really. It's full retraining. It's the really super expensive $78 million retraining on data, that sort of a thing. Just as a full watch, like retraining the whole data, dumping everything we know, cleaning up the data set, and retraining from scratch. That's super hard, right? And there's a separate mechanism called compartmentalization, or SISA, which stands for sharded, isolated, sliced, and aggregated training. And that
sounds like music to me.
Yeah, right. That is what it says in the tin, which is to say, data is, instead of it being a single or kind of diffuse set of training, you have broken up the training data sets into shards, and you have done a better job identifying those shards. And so then when someone sends you a request to remove things or to take down a copyrighted work, you can theoretically go back and look in your shards, erase it from that shard, and then move on with your life. It is supposed to be it is a more efficient method. But again, it kind of relies a little bit on the organization, the foundation model foundation model developers, to kind of have good data quality and process in place. And right now, I just don't think that that's there yet. And most of these approaches, most like SISA, for instance, or retraining, they're mostly looked at in these much smaller, more discrete model frameworks. But SISA is probably an approach that could be considered. It is very much, in my analogies here, sort of like basically taking someone's brain out of their existing body and whacking it into a new body, kind of altered carbon style. So basically saying that the body in this case is the training data itself, and the brain is the machine learning model. So kind of swapping. And so it's doable. Well, it's not, the body brain altered carbon thing isn't doable, but that for machine learning is doable. There's a lot of limitations there, right? So just like retraining that we talked about earlier, it's super resource intensive, it's super costly, it's wildly impractical on the kind of timeframes and timescales that most laws are set up for. even compartmentalization kind of requires that you have really good really good data quality standards in place. You really understand what those shards are, and you understand which shards have what information about any given thing. So that's really hard. It is technically better than other approaches like approximate unlearning or federated unlearning, potentially because it is considered guaranteed, at least from a computer science sense of the term. In other words, if you find the right data and you remove it, or you take it out of the training set entirely and you retrain the model from scratch, it's not going to be there anymore. That's not to say that an output may not generate something that is itself legally problematic for other reasons. But as far as a controller would be, like OpenAI, for instance, I think that they could legally potentially have a stronger argument to say, at least going forward, they are complying to the best of their ability. Fundamentally, it also requires access to the training data. So anyone who's a deployer and whacking things on top of an existing large language model system is not really going to be able to do this because they won't have access to the training data. And it does potentially have effects on model quality. So that's exact unlearning. It's relatively straightforward and easy to understand. The messy bits are in the other categories. Excuse me. So the next is approximate unlearning. Approximate unlearning is basically, if I'm going to be generous, this is the part where all the computer science kids and the machine learning kids and the mathematicians get really excited about it, because it involves various degrees of esoteric math and sexy computer science things, and they love that stuff. From a practicality standpoint, I am continually suspect, because most of the time these approaches are treated are taken against small language models or against very isolated, discrete things like an image data set or the Harry Potter book and nothing else, right? And these get there's a lot of different categories. I could spend 3 hours talking about the different categories within each, but what I tried to do was group them, again, using my very, very strained neurosurgery, repairing neurological disorders examples. So there's kind of the brain surgery approaches, things like gradient-based unlearning and selective forgetting. And these are different methods of basically cutting out by tweaking the weights, trying to cut out the connections between say in a language model, Carey and Lening. They are a bit more robust, but they're difficult because you have to find where in the model those things exist.
Back to square one.
Yeah. And also they have a potential to really impact other aspects of the LLM or other aspects of like the image learning model or whatever it is you're talking about. The other thing is it's kind of a blunt force tool. You don't necessarily have granularity on how to identify the specific Napoleon or the specific Bob Smith. You kind of have to just whack at everything that's related to Bob Smith or everything that's related to Carey Lening or everything that is potentially a mouse that could be copyrighted by Disney. So it's a little problematic. The next set of things are kind of what I call drug-based approaches, which is to say they are kind of intermediating and stepping between the system and saying kind of like a blocker. There are techniques like Bayesian unlearning and representation-based unlearning, which focus on essentially telling, let's pretend like you have a neurological condition or something and you want to stop that neurological condition from happening. You might take something that blocks a synapse from firing. Mm-hmm. That's kind of what these approaches are doing. They are telling the thing to kind of stop the association between what the language model already knows. And so by modifying, for instance, in the representation based on learning, by modifying what the system knows about representations between words or images or whatever it is, the developers can control the model's behavior to remove the influence of that data. The third technique, and this is the one that I have seen at least a little bit in practice in an applied way, as opposed to a theoretical way only, is model editing and fine tuning with random labels. These I call brainwashing techniques. And what it basically is convincing the system that what it knows is actually something else. So if I want my LLM to unlearn Harry Potter, without it necessarily degrading all of the model, I might say, instead of Harry Potter is a wizard at Hogwarts or whatever, I might go and say Harry Potter is a janitor from Cleveland. I give it something else to weight the Harry Potter to.
Isn't that what Microsoft did? I remember reading an article about that.
Yeah. That's
I think that was the example. I
Yeah.
think they had a kind of a use case, the Harry Potter use case where they trained the model to do just that.
Right.
After they brainwashed the model, he started saying that Harry Potter was somebody else entirely. Yeah.
And so you're in the fine-tuning process, excuse me, or the knowledge editing process, you're basically pumping the system full of knowledge that says, no, Harry Potter isn't a wizard at Hogwarts. Harry Potter is a plumber in Cleveland, or whatever it is. You're applying random labels. And that creates some interesting challenges, I think. One of them is around, the data protection ideas around accuracy. In the law, in GDPR, and in most of the US-based laws or other data protection laws, there is these concepts, these kind of fundamental principles. One of those fundamental principles is around accuracy. The data must be kind of accurate and complete and true. And so if you apply these kinds of model editing things, especially if you're applying fictitious or kind of random labels to it, I don't know how you successfully maintain accuracy at that point. You could tell the system that Carey Lening only likes dogs and hates cats and lives in Japan, but that's not accurate about me. That's not really, also, it's not really erasing information about me. It's not really forgetting information about me. It's just convincing the system that I'm something else. And so then there's other kind of different approaches. Knowledge distillation is a mechanism for training a model to basically associate something else. It takes another language model, a teacher language model, and a student language model, and that teacher language model tries to guide the student model to provide better information. And then there's data set emulation, which is kind of instead of the engineers providing a specific example, you kind of have the system be fixed with synthetic data. I have big problems with the synthetic data argument because I think it's wonderful in theory, but I haven't seen anyone actually do it in most cases at scale in practice, and it runs into its own set of problems, similarly around accuracy and around whether or not the data is actually synthetic and where it's learning from and everything else.
There are a lot of proponents of synthetic data, and people are like, oh my God, synthetic data will save us all. It's just, our magical button.
And there's definitely, there are use cases. I have seen some synthetic data being used in small scale, like medical trials, or in, to assist in differentially private techniques, again, in kind of these isolated contexts. frequently in academic contexts, although I know that some people are going to jump up and down and tell me that there are applied use cases as well. Please come out and talk to me because I'd love to find out more. I really would. Um, but I don't know how Meta applies synthetic data or could apply synthetic data to the llama model, for example. I think it would just be really, really complex and costly and very difficult to actually implement at scale. And then the final bit is kind of hypnosis and mind altering drugs. This is the way I use it is these aren't even really.
Carey, so sorry to interrupt. We actually should have put that on the screen. Now that I'm thinking, brainwashing, gaslighting. I have to revise this presentation because I mean, to me, these metaphors, I mean, the analogies, very straightforward. It's like, oh yeah, I get this.
Yeah. It's much easier than just exact and approximate and all the other different things.
Yeah, like differential privacy. I told you I was struggling with this concept. It's like,
oh, I'm struggling with differential privacy too, and I'll get to that in a second. Yeah. But I'll just hit the mind altering drugs thing. There are some techniques that are that could be applied by basically pumping the LLM with kind of adversarial techniques to get it to forget or get it to associate something else. The benefits of these, of course, is that they are don't necessarily require access to the training data. But again, I've only seen these used in very small contexts. So, but it's interesting. Let's talk about differential privacy. Okay, so again, it's like synthetic data with me. I have talked to people who swear up and down that differential privacy will save us. And I have seen some use cases. Obviously, everyone trots out the US Census. And there are 100%, I'm sure, use cases where you can have basically a certain privacy budget and a certain set of information such that you can keep data from being able to have enough information to identify someone through different means. Lots of math. The math makes my eyes glaze over, but effectively it is really just saying we need enough noise, we need enough other information in the training data in the system to make it so that there is no way that information about Elisa or Lena or Carey actually can be discovered. The thing with the differentially private techniques that I have seen is that I don't know how that applies outside of the training model approach. Like, I don't know how you do differentially private techniques. And I haven't been able to understand, based on my research, looking at the different research papers and everything else, how you apply the differentially private techniques as a mechanism once the model is trained. You can apply it to the training data. And you could, of course, retrain. That's totally a thing. But I don't know how you do it after. It's not like the other kind of exact unlearning techniques as far as I've been able to tell. So most of the time people are using differentially private techniques as a testing or measurement mechanism for other approximate unlearning techniques. So that's it. And again, I'm waiting for the haters to come out and tell me I'm wrong. That's fine. I have told people many, many times that I am no expert at these things. I've just been spending time reading stuff. And so maybe I get it wrong and maybe I'm missing something really, really profound. But yeah, I don't know. So like the exact unlearning techniques, a lot of these approximate techniques suffer similar problems. Not necessarily in the computational expense aspects, but in the scalability and feasibility at when applied to large language models. Most of the research is kids using it for, a specific image set that is well defined, and that's the only thing that it's actually trained on. And then you want to remove a picture of a dog or a flower or whatever. And it's a relatively easy thing because they don't have to go hunt too much to find where that dog or flower is. They know that the model is discrete enough. It's not being trained on crap from the internet. It's being trained on a very specific set of things. The other big problem is we talked about catastrophic forgetting earlier. some of these approaches can have lots of unintended consequences for the model overall. So they can affect other aspects of the training model in a way that you don't really want to, like forgetting factual details or forgetting sentence construction or forgetting, let's say, details about, you know, the public domain information that is perfectly fine to know. The other is bias and fairness issues. We talk a lot about bias and limitations on the data sets that these models are trained on. And especially properly for large language models, when they're being trained on trying to learn about less spoken, more isolated language families, there is a huge risk that, if you have it forget, like let's say you go after the Xhosa, which is a language in, certain tribes speak in Africa. It's a relatively common one, but there's not a lot of written text about it. Mm-hmm. But let's say the people who have the large corpus of this text file a copyright infringement claim. If you wipe out all of the Xhosa text because of copyright, you lose the model's ability to translate, to do things with that data. Or if it's a medical system or a medical situation, and you're trying to deal with rare diseases, and you take out, one of the 5 patients or whatever, or one of the 10 patients that have that particular medical condition, it risks having substantial impacts on the model. I've talked about the difficulty in generating synthetic data, and I've mentioned the perennial problem of identification complexity as well. So, yeah, that's the kind of issues with a lot of the approximate unlearning techniques. There's a newer thing that's on the town called federated unlearning, and this one's fascinating to me because I don't know if folks know what federated learning is specifically, but federated learning or on-device learning is a way to basically share information and develop a model without necessarily leaking private information. It's really cool, and it's something that Google and Apple and a few of these other companies are actually using in the wild. So Google's Gboard is probably the most canonically well-known example. So the way Gboard works is if there is, it has a certain knowledge about what different, swipe terms are. You swipe, I'm coming to dinner. Well, it knows that. And if you start swiping with your finger, it'll predict those terms, right? But, when COVID happened, it didn't necessarily know what COVID was. It didn't necessarily know what all these, N95 was, or it wouldn't necessarily predict that in context. So Google used federated learning to have a whole bunch of, individual informations where each device has a small language model or has a language model or a machine learning model on its device. And it learns, and then it sends its learnings, its embeddings to a smaller group. And then that smaller group kind of combines, and then they send it to like a centralized server. So the goal of that, of course, is that no personal data is actually being shared. They're just learning the embeddings. They're just learning the connections. Mm-hmm. And it's really cool. And I think that there's a lot of promise with federated learning. Federated unlearning then is that process kind of in reverse, trying to apply it to unlearn things. And there's some really interesting tech out there. There's also a really hilarious Google AI comic strip that I highly recommend everyone read because it's brilliant and it's kind of funny, which is brilliant explainer plus funny is automatically my favorite thing in the world. So the federated unlearning techniques basically kind of are forcing an ability to pull out specific model details that that my device may have provided that eventually end up in the centralized, embedding, finding a way to actually pull that out. Those are really interesting. And I'm still trying to dig in to a couple of things. One is the different mechanisms that are out there, because I'm still working on the final parts of this article. So understanding more about what these different techniques are and how they work, and also fundamentally understanding the limitations of these techniques. So I have less information there than I do about the other ones, because I'm still kind of working at it and getting through, because again, this is probably the newest research in this area. But some of the issues, of course, that I have seen and that have been identified in the research are obviously around the same things that you would see in an approximate unlearning technique, or in feasibility concerns, because it's not exactly like exact unlearning, because you don't have to necessarily take apart everything, but you still need to be able to find where the information that my device has sent actually comes from, and like identify my specific information and remove it. And one of the things that I've been thinking about is, if federated learning is done correctly, is it even personal data that Google or Gboard or Apple's Siri or whatever it is actually has? Is it learning information about me, or is it just learning those embeddings and connections? And going back to my earlier point, I don't think those embeddings and connections are personal data. So that might be an opportunity and a way to give some cover or legally comply in a way that is more feasible than, say, exact unlearning methods or some of the other things. So yeah, so those are the unlearning things. And then there are some other stuff that is not technically machine unlearning. It's other things. It's output suppression and filtering and text-based classifiers. And so this is basically closer to our traditional notions of databases. Basically, there is something intermediating in the middle. When I send an input to ChatGPT, who is Carey Lening, it now gives me, I'm sorry, I can't tell you, Dave, or, the variation that they have, which is like, I'm unable to comply with this request or whatever. And what's interesting there, of course, is while that arguably satisfies right to be forgotten, and I have a big hand wavy set of asterisks there, it's not really erasure. It's not really deletion. And certainly can't be rectification.
Mm-hmm.
So because the data is still there, like everything is still exactly as it is. It's just applying a big filter on top. It's applying. There's a Black Mirror episode. I don't remember what the name of it is, but basically they start out and everyone's wearing these like glasses or these contact lenses, and there's filters on them, so that if you see certain things you don't want to see, you see gore, or you see brown people, or whatever it is that it was kind of dystopian and screwed up. So it was like, you didn't want to see the opposing side, the out group. It'll put a filter up. And so you just see kind of a silhouette of a person, but you don't actually see what's in front of you. To me, that's what those approaches kind of feel like. They're not really erasure. They're not really rectification. They're not really removing anything. They're just putting up a barrier. And that's done by a couple of different mechanisms, mostly, again, basically whacking a RAG model on top of it that says, if I do a search for who is Carey Lening, it comes back with a result that says, I'm sorry, I can't provide information to you. But it's not doing anything to the underlying connections or embeddings or anything.
Interesting. So do you think this is where the data controllers, under the GDPR, for example, will kind of have issues with meeting their obligations under, existing regulations? Or because I mean, again, as you where we started, right, when you just kind of were talking about the problem itself, how we perceive the LLMs, and whether they're databases or not, and whether the same set of legal rules would apply and would actually cover the LLMs the same way that they cover the databases in kind of in a traditional sense. So I don't know.
I don't I don't either, and I'm kind of looking forward to seeing the guidance that comes out from the regulators. Obviously, California has passed AB 1008, and they have a whole different things where they basically said that this stuff does count as PII, or personally identifiable information, or personal data, and so I don't know. It's gonna be interesting.
I think they're trying to kind of enhance and maybe just kind of apply this concept to like the abstract data as well, just to make sure that all of this is covered. I don't quite remember. We'll have to read that again. But it's really, I mean, there's really no answer. This is kind of
not yet. Not yet. It's fun though. I mean, it's a fun weird little gray space that we're all operating in right now. I think my kind of perspective on this is that it's going to require a bit of an evolution in a lot of things. So it's going to require a little bit of grace and change in the law, because, obviously there needs to be a recognition that this stuff is not easy. And if we're not going to allow for technical impossibility to be an answer, we need to have at least some more understanding of like, okay, well, if this thing costs billions and millions and millions of dollars to do, and we can't necessarily guarantee it, maybe we need to figure out a happy medium there. I think another thing, or we need to ban LLMs. The regulators need to actually, like, as my grandmother would say, shit or get off the pot on this. If they really are serious and they want to be absolutist about it and they don't want to have any flexibility, they need to ban LLMs. That's the bottom line. I
don't think this is happening, Carey, at all in the United States. Absolutely not. Because
but in Europe, maybe, I don't know.
Of course. I mean, we have this two kind of two different legal systems that we're talking about here, but also, I've heard some folks already saying that, with the new presidential administration, we're gonna go down the deregulation path. So definitely no federal level legislation on those, things. But even like for, we have a bunch of states that have either enacted or in process, like Texas. So definitely, I mean, I guess the vibe right now is going to be more freedom, less regulation. Definitely not being absolutist about it. So maybe the argument of technical impossibility, of how you worded that, that argument will get more weight. I don't know. We'll see. And also we have a bunch of lawsuits that still none of them has gotten to trial yet, but they will, I think, next year. So this is also going to be very interesting, and that's mostly the copyright related issues, right? So
but I do think fundamentally the law is going to have to change, or at least be more flexible in some respects. Which is not to say that we don't have rights in data protection, we don't have rights in personal data, because I'm not arguing that at all. But what I am saying is, like, okay, maybe we have to come to terms with the fact that an output is not and should never be treated as truth. And that, of course, affects how we use LLMs, right? That affects how we use chatbots. That affects how we develop things in the first place and the kinds of business models that we can use those things with. And so the AI Act may potentially have to broaden what those use cases, or what the prohibited use cases or the high risk use cases actually should be. I think I would like to see the industry move away from the ChatGPT style large language models to more small language models that are more constrained and more niche to different use cases. We don't use our refrigerators to store bodies, right? You might use refrigeration to store a dead body, but you don't use your refrigerator to store a dead body. And so maybe we need to have a little bit of a reevaluation as to the kinds of models we use. I think that there's definitely going to be constant new research coming out. maybe it will be a combination of many different research, many different approaches, something like output suppression and text classification, and maybe this, new labeling process and something else. And maybe that will work. I don't know. Maybe the federated learning and unlearning processes will be more developed, and then that will help. Or maybe we just kind of go, okay, we can't treat this data like it's personal data, because we can't treat the outputs like it's personal data, because it's in some respects kind of a little bit not hallucinated, but it's probabilistic. It's not a consistent output necessarily.
Okay.
We can't treat this like databases, in other words.
Yeah, I think we're out of time, but
we're out of time. 5
Yeah.
minutes already.
Yeah, sorry. I talk too much. I'm sorry.
No,
This is really fascinating.
Yeah, this
That's
is so interesting because, I mean, we have all these, regulations here and there, all these obligations. You have to do this, you have to do that. But how does it practically translates to when you actually are, when this actually comes down to some practical application of those things, how this can be done, right? And why should people even care?
Well, I mean, people care because there are lots of negative consequences, right? If the HR chatbot decides that you, Elisa, are a convicted murderer because you share the same name with someone else,
Yeah,
that's really bad, right? That would be really ungood. And of course the companies care because sometimes they get fined and they don't like that very much, and it's a big drag to be yelled at by the regulators constantly. I mean, just ask Facebook. Not that they don't deserve it sometimes, but it is kind of a pain in the ass, and it does create some problems.
It is a bad PR because these things are in the news all the time, I guess.
Yeah, and if copyright lawsuits come down and it's negative for model or for LLM providers, I can see that having a massive impact. I can see the potentially the Digital Services Act, if it broadens, and some of these other kind of social media type laws having an impact. Texas seems to go crazy every week and come out with new things to control what is harmful. So if these laws get elevated and enhanced at the state level, that can create lots of problems. So there's a lot of reasons to care, and of course, people's fundamentally are being harmed in some cases. Like the outputs do have consequences. So
there are
that's why I care.
There are a few defamation lawsuits that I can kind of get off top of my head already. So I mean, plus don't forget about AI agents, the new shiny thing on the town.
Yeah.
A lot of things can go wrong.
That's right. A lot of decisions made. So anyway, thank you, ladies.
Right.
This was really
fun.
Thank
you so much.
I enjoyed it.
Yeah, thank you so much for joining us from Ireland. It's getting late.
That's good.
Getting late.
Yeah.
Thank you so much, Carey.
You've had a long week. Thank you so much for coming time to talk to us. Yeah. Into our audience.
All right.
Thank you so much.
Right.
Thanks.
Thank you. Thank you, everyone.
Bye.
Bye, everyone.